Hello, welcome everyone. Am I audible to everyone?
Yes, sir.
Yeah, welcome everyone. Myself, Manish Barot, Head Technical Business Development and Technical Sales. I'm inviting you all for today's webinar on application of geosynthetic in ground improvement. Here we are going to cover brief regarding what is ground improvement, why ground improvement required, what is the different solution available for ground improvement, conventional as well as advanced, and we focused on ground improvement with help of the geosynthetic for the cellular foundation. For the road and associated works, so my colleague Mr. Isfaq Hamid will start the presentation by company introduction. So again, welcome you all, and Isfaq, now you can start.
Thank you so much, sir.
Thank you. Thank you.
Good evening, everyone. Before initiating the presentation, I would like to thank you all for joining today's presentation. Well, in continuation to the knowledge sharing initiatives of TechFab India through various webinars, we are pleased to add another initiative today, as Manish sir has already told, that which shall be on application of geosynthetics in ground improvement for roads and associated works. So before I'm beginning this presentation, I would like to give a brief introduction about my organization. Well, TechFab India, we started in the year 2003 with a dream to give India world-class geosynthetic products. We started our manufacturing by manufacturing non-woven geotextiles. We have rapidly grown to manufacture woven geotextiles, reinforced geocomposites, geogrids, uniaxial, biaxial, polypropylene, polyester, geocells, geotextile bags, geotextile tubes, fin drains, to become the largest manufacturers of geosynthetics in India. In addition to the geosynthetic manufacturing, we have also been manufacturing the double twisted wire mesh gabions and mattresses, all intended to serve the infrastructure development in India for the problems persisting to ground improvement, urban roads, airports, highways, river training and protection works, coastal protection works, and RE walls. Well, we as in TechFab India, we achieved Best Geosynthetics Manufacturer Award in 2018 by Indian Excellence Awards. And we are ranked #1 by Ministry of Road Transport and Highways among all the geosynthetic manufacturers which are present in the country. Like you can see, this is the annexure for the circular which was circulated by Ministry of Road Transport and Highways. You can see on #1, TechFab India is mentioned as the highest manufacturing installed capacity of geosynthetics. Well, we in TechFab India, we believe in quality. So TechFab India products are approved by AASHTO and NTBP globally. And though TechFab India's high quality products, we have a ready acceptance in large number of countries. And that's why we export our products to over 35 countries all over the world. Now coming to the baseline of today's discussion, which is application of geosynthetics in ground improvement for roads and associated works. Well, before beginning the applications of geosynthetics, I would like to give a brief introduction about the basics of ground improvement. You know, we as in the engineers, we face difficult ground conditions at a project site. We have to employ various possible strategies to achieve the project objectives. The strategies include modification of the existing physical properties of underlying ground in order to enable effective, economic, and safe construction in practical timescales. So we can say that a process to alter or improve underlying poor ground conditions containing superstructure by various geotechnical construction methods for countering insufficient stability, increased settlement, and insufficient bearing capacity. Well, the presence of poor or soft underlying ground, which is the basic cause for ground failure, includes the soil susceptible to failure and excessive settlement, including soils with fine soils having very low undrained shear strength, soils with very high compressibility, and soils with very low permeability. When the failure, it happens at undrained condition within a short period after the embankment is constructed. Well, on the similar note, the various failure patterns which are associated with this soft ground or poor ground are foundation extrusion, rotational failure, lateral sliding, and overall failure. Well, the foundation extrusion is the lateral extrusion of foundation beneath an embankment. Rotational failure is your global failure. Foundation extrusion at horizontal moment of fill, that is your lateral sliding, and a deep-seated failure that leads to the overall failure of the entire foundation. Well, looking into the failures, the cause of the failure, and the various failure modes associated, there is a need to prevent these excessive settlements of subsoils containing structures like buildings and roads. There is a need to improve shear strength of the fill to ensure sufficient bearing capacity of foundations. And there is a need to increase the density of the fill mass to prevent liquefaction. There is a need to improve the permeability in order to increase the drainage capacity. So in a nutshell, we can say that there is a need for improved stability. There is a need for reducing settlement. There is a need for improving the bearing capacity. And there is a need for reducing liquefaction or improving the resistance of soil against liquefaction. Looking into all those needs, all those do's and don'ts, we have seen since earliest times, humankind has found ways to deal with poor ground using simple strategies. And the various successful strategies depending upon the type of soil, construction feasibility, commercial aspects, and performance requirements. We shall be discussing about them. Among all the conventional measures of ground improvement, the first technique which I shall be talking about, which comes very handy, is soil replacement technique. When unsatisfactory material is encountered at or near to the surface, it may be economical to remove part of it or all of it. And generally, we have seen that in high embankment projects, removal of 1.5 to 3 meters of unsuitable material from original ground level may be possible for the full width of the fill. Areas of swampy areas and peat and mud deposits, such type of technique is generally found to be very effective. However, on the whole, this will be governed by the costs involved related to the other methods, because anyways, you are going to extract the amount of fill and then you are going to replace it with some good fill, and that good fill has to be available over the vicinity of the area. Another method is staged construction. Well, staged construction is also a simple and economic method for accelerating consolidation as compared to other ground improvement methods. As the name specifies, it's filling of an embankment at a controlled rate to permit increase in shear strength due to consolidation without failure. However, as it is being told that it's done at a controlled rate, so adequate instrumentation measures has to be taken care of while we are employing such type of technique for ground improvement. Another technique is stabilization, whether it be chemical stabilization, lime stabilization, or cement stabilization. Well, there's a saying which is being said about lime, that lime is an excellent choice for short-term modification of soil, especially where the subsoil is of expansive nature, like black cotton soil. And when depth and extent of poor soil is large, then cement stabilization can be opted. And there are other chemical techniques wherein chemical additives you are adding to the soil in order to form a stiff platform, a solid working platform. Well, the basic intent of this technique is to reduce the plasticity, to reduce the moisture holding capacity, to reduce the swelling index soil, and to improve the stability. Well, for more details, you can refer to IRC SP89, which is guidelines for soil and granular material using cement, lime, and fly ash for the entire design methodology and the beyond steps of it. Another technique, talking about the conventional techniques, is preloading. It's somehow similar to that of the staged construction, But other than the stage construction here, and heavy weight, a surcharge weight is placed and on the top of the embankment in order to increase the rate of consolidation. But as I told you, in case of staged construction and in case of this preloading, adequate instrumentation measures for monitoring the settlements and dissipation of pore water pressure should be essential. Another technique is your consolidation. There are many consolidation techniques, but one of the most effective technique which is used to improve the strength and compressibility characteristics of soft clays is stone columns. Well, found by making borehole and backfilling the same with compacted stone. That is what we call as stone columns. And stone columns are nowadays replaced with the inclination of PVDs. However, the entire in-depth procedure for how we go with the design techniques and all, they will be explained in our next session, which my senior colleague, Mr. Premal Shah, will be explaining. So let's now quickly move to the basic context of today's discussion, which is methods of ground improvement involving geosynthetics. Geosynthetic materials have been used to improve the bearing capacity of the soil and the settlement performance of shallow foundation. From past few decades, several studies have been conducted based on laboratory models and field tests related to the beneficial effects of geosynthetics on load bearing capacity in roads and associated works. However, today we will be talking about the ground improvement techniques using basal reinforcement, Geogrid at the base of the foundation, ground improvement technique using basal reinforcement as Geocell mattress at the bottom of the foundation, a subsurface drainage layer used at the base of the foundation for improving the ground, and a separation, a geotextile layer placed at bottom of the foundation. The other methods like basal reinforcement were piles and staged construction with inclusion of PVDs and geotextile encased stone columns will be covered in detail in the next webinar, in the next upcoming webinar. So we can see that today ground improvement for shallow foundations supported by soft soil reinforced with reinforcing materials like Geogrid, Geocell, drainage composite, and geotextile will be the main crux of today's discussion. Now, geosynthetic basal reinforcement, a technique wherein a high strength and stiff geosynthetic reinforcement layer is placed at the base of an embankment in order to improve stability, is what we call as geosynthetic basal reinforcement. Well, this reinforcement is placed at the base of the structure in order to ascertain the local failure, that is slip within embankment fill, a rotational failure or what we call as the toe failure, the lateral spreading, that is horizontal movement of the fill, or the deep-seated failure. Now, what happens when we are placing a geogrid at the bottom of an embankment of a foundation? For any basal reinforcement technique, when you are putting your reinforcement at the base of an embankment, let's say, at the end of the construction of an embankment, the entire loads are being encountered by the reinforcement itself. But with passage of time, consolidation in the foundation is happening at certain rate depending upon the type of the soil, type of the loading, and after some time, let's say 5-10 years or whatever the time of consolidation is there, the foundation soil itself gains enough strength to cater all the loads which are coming onto it. So we can say after a certain period of time, the foundation is sufficient enough to cater all the loads. Okay. Now, the contribution of reinforcement for stability of an embankment. Since I've told you that today we'll be talking about basal reinforcement using geogrids, geocells, geotextiles, and drainage composites. So herein we will discuss the contribution of each layer of reinforcement. You can see in the slide, there are two cases. First case is an embankment that is unreinforced. No reinforcement is placed at the foundation level. And second case is an embankment wherein a reinforcement geogrid is placed at the bottom of a foundation as basal reinforcement. Now, in this case, when we are not putting any reinforcement at the base, there are forces, vertical and outward shear stresses, which are acting onto the foundation, leading to the problems like slip failure and lateral extrusion. Okay. Now, in order to encounter the same problem, we are putting our reinforcement. One second. Yeah, we are putting our reinforcement at the base of a foundation. Now the vertical and the outward shear stresses are being countered by the reinforcement. The intensity of the vertical forces is reduced to some extent due to this geogrid, and the intensity of outward forces is totally proposed or is totally opposed by the reinforcement geogrid. Finally, tending to the inward vertical shear stresses which are developed post reinforcement. So in this case, we are dealing with, and finally, we have dealt with the problems of extrusion, foundation extrusion, and global slip failure. On a similar note, contribution of reinforcement, geogrid reinforcement at the base of an embankment. Again, comparison with unreinforced case, a reinforced case when we are talking about an embankment wherein at the base we are placing a geocell layer, a geocell mattress layer as basal reinforcement, the vertical and the outward stresses are getting dispersed by the confinement and stress dispersion effect of the geocells. So the loads which are coming onto the foundation are dispersed and their intensity is reduced to maximum after using this geocell reinforcement at the base of the foundation. Again, the contribution of separation or drainage layer for stability of embankment. A similar case, earlier we used a geogrid, then we used a geocell. Now we are using a high strength woven geotextile at the base of the foundation. Now a high strength woven geotextile in the base of the foundation will prevent the intermixing of two different fills, will reduce the stresses to some extent because it's a high strength woven geotextile, so it comes with a strength. And if the same geotextile, high strength geotextile, is replaced by a drainage layer, let's say drainage composite, which is a combination of non-woven geotextile and a high strength polypropylene core. A high strength polypropylene tensile strength core, which is sandwiched in between two non-woven geotextiles. The two non-woven geotextile will act as the medium, which will prevent the intermixing of two different fills. And the polypropylene core, since it has its own strength, will add additional strength, will reduce stresses coming onto the foundation. And further, the drainage core will maintain the safe passage of pore water throughout. So depending upon the type of the problem, the type of the scenario which we are facing at the site, we can choose among the different methods, which method we have to opt, we have to choose accordingly, because looking at the problem, what do we need? Okay, we don't have that much amount of stress to disperse. We have to only use a separating medium, then we can go with woven geotextile layer. Or we have to improve the drainage, we can go with the drainage layer. Or else if we are having enough stresses coming onto it, then we can
Hello, Ishfaq.
Not able to hear Ishfaq.
Ishfaq not able to hear Ishfaq.
Ishfaq, your connection is gone.
Let us wait, he will join back.
Yeah, wait for 1 minute. I will call.
No,
Ishfaq?
He is unmuting it.
Hi, Ishfaq.
Now it's audible, sir.
Yeah. Continue.
Sorry, sir. Sorry, there's some network problem with my area. So
Yeah. Continue.
okay. So what I was talking about was among all the different methods which we were discussing, like you are placing an high strength geogrid at the base of an embankment just to take care of the local failure. you can just use that technique. Or else if there is a problem that our foundation is lagging in bearing pressure, lagging in bearing capacity, then you have to improve the bearing capacity of the soil, or you have to reduce the stresses which are coming into the foundation. Then you have to go with another method, that is using geocell methods at base of the foundation. Okay, that is another basal reinforcement technique. Now there is another problem that the stress dispersion and reducing the stresses is not a big difference, but still you have to just separate two different mediums, two different filling mediums. Then you can go with an high strength woven geotextile which is placed at the foundation level. Okay, and if there is an problem wherein you want to only take care of the drainage which is coming onto it, so that to make the maintain the safe passage of pore water, then you can use a drainage composite layer in between the foundation and the embankment fill. So depending upon the problem, the sort of problem which you are facing, you can choose any of the methods which we were talking about, because depending upon the contribution of the reinforcement, the entire design methodology will be working on. Now talking about the design methodology, the design of geosynthetic reinforced embankments on soft soils is mentioned in IRC 113213. It's just as per section 5.2.11 of IRC 75-215 and section 3 and section 5.1 of IRC 113213. Well, the design methodology is simple. It involves determination of effective pressure coming onto the foundation, then considering a trial reinforcement at the base, then determining the safety factors against rotational failure using slip circle method, and determination of safety factors against lateral sliding. So once these factors of safeties are coming safe, then your trial reinforcement is okay. If it's not coming safe, then you have to go with increasing the reinforcement. You can increase the grade of the reinforcement. By grade, I mean to say the tensile strength of the reinforcement has to be increased, or you can increase the number of the reinforcement layers, or just reduce the spacing in between the number of the layers, because there are a lot of things which will benefit upon once you are just interpolating the data for designing an geosynthetic reinforcement embankment on soft soils. On the similar note, the evaluation of bearing capacity calculation methods for Geocell have been given by a lot of researchers, like Kohner's method is there, which is given by Kohner, Presto's method is there, apparent cohesion method is there, and Avasani-Neto method is there. Well, the most common thing among all those methods is that the methodology involves initially determining the effective bearing pressure on the foundation, then again considering a trial reinforcement at the base, then determining the reduction in pore pressure due to reinforcement, because as I told you that Geocell has an stress dispersion and confinement effect which will reduce the pressures which are coming into the foundation. Okay, then determining the safety factors against bearing failure, and though we have reduced the pressures which are coming onto the foundation, then accordingly there can be found still some sort of reduction in the settlement also. Then you determine the safety factors against settlement, and if it's coming safe, then it's okay. If it's not coming safe, then we have to interpolate the data again. Now, how is it done by TechFab India? Because we have been dealing with problems of ground improvement, and we have been employing Geocells and Geogrids for the same from a very long time. So I got this opportunity of sharing with you a sample calculation so that I can tell you that how exactly it is done when problems like that come to TechFab India. As an input, you will get an maximum gross weight that is coming onto the foundation, okay, from which we can just calculate the maximum bearing pressure which is coming onto the foundation. And you will be getting the foundation properties, the shear parameters of the soil. Now looking into the shear parameters of the soil and the maximum gross weight or maximum bearing pressure which is coming onto the foundation, you can initially calculate the safe bearing capacity of the soil. Yeah, you can calculate the safe bearing capacity of the foundation. Then you can compare it with any of the conventional methods. Like in this calculation with such shear parameters and with such loading, I have done two different iterations. The first iteration was done by replacing a patch of soil beneath the underlying structure. Okay, when it was replaced, let's say 1.5 meters of sand patch was replaced with good soil. After replacing it with good soil, there was certain improvement in shape bearing capacity which was found, but still that improvement was not sufficient enough to cater all the loading which was coming into it. So that was only for 1.5 meter of replacement of soil. But for the similar case, when we used our geocell, 1 layer of geocell filled with sand, we have found that after employing this geocell, the pressure coming onto the foundation was reduced, the intensity of pressure was reduced, and finally the bearing capacity of the soil beneath the foundation was sufficient enough to cater all the loads. So this is how it works in comparison with all the conventional things which you have. In addition to the ground improvement, in addition to the ground improvement implication of geocells are also used for subgrade stabilization and thickness reduction, as the details are mentioned in IRC SP 59-19, and the detailed example as mentioned in annexure number 4 is mentioned in IRC SP 59-19. So geocells can be used to improve the effective CBR of prepared subgrade, and when used in granular material, they can result in considerable reduction in thickness with the corresponding layer. For the entire design methodology, you can refer to IRCSP 59-19 with a stepwise installation methodology they have mentioned over there in conjunction with IIT PAVE and IRC 37-18. You can just design the same. There are some projects of PMGSY and PWD projects wherein we have employed such sort of methodology for subgrade stabilization. A few case studies I have also attached. I will be sharing that knowledge with you in the upcoming slides. Well, the geosynthetic ground improvement, especially when we talk about the geocell ground improvement, the geocell ground improvement, it depends upon the lot of factors. Let's say bearing capacity of geocell reinforced cell change with various factors. There's the type of reinforcement you are using, the number of layers of the reinforcement you are using, the weld spacing, and the cell depth. These two parameters have a great influence on reducing the pressure which is coming onto the foundation. Well, depending upon the basic design methodology of the geocell load reduction procedure, the geocells which we are providing and manufacturing are textured with polyethylene strip consisting of multiple rhomboidal indentations over the entire strip area on both sides. Well, the advantage of having multiple rhomboidal indentations on the entire strip is that the indentations or the textureness on the sides of an geocell enables an interface friction in between the fill and the cell, and that reduces the pressure which is going into the foundation, though the intensity of pressure is also reduced after getting a geocell which is textured. Further, our geocells are perforated. Polyethylene strip is perforated with horizontal rows of minimum 10 mm diameter holes. Well, once a geocell is filled with a granular layer, and these holes will help in maintaining the effective drainage within the area. Let's say, for instance, you are using a geocell for subgrade stabilization. You are stabilizing the prepared subgrade, but though you are also improving the drainage capacity of the entire pavement structure. The various variants of geocell which we manufacture varies with weld spacing varying from 330 to 712 mm, and the cell depth varies from 75 mm to 300 mm. Well, the new development in Indian standards, especially when we talk about BIS, due to the advancement of geotechnical engineering and the use of geosynthetics for improving the poor, unsuitable ground conditions, a lot of research which was done by renowned geotechnical engineers all over the globe has been revisited, and the processes have been initiated already about a decade ago to incorporate the same into various Indian standards, beginning with the revisions which were made in the Indian standards like IRC 37, SP 59, IRC 75, IRC 11389, and other design guidelines. Other than that, BIS have also worked into the formulation of such guidelines like Ganga Flood Control Commission, GFCC has prepared a different guideline for the use of geosynthetics in river training works. CWC guideline is also there. But from past 5 or 10 years, IRC and BIS has speedily started revising and drafting new codes and standards for the use of geosynthetics in geotechnical and hydraulic engineering applications in order to minimize the exploitation of natural resources and to reduce the emission of carbon footprint. Well, looking into that initiative, few codes, BIS codes, which were published last week, which is an drafting, which was done recently, is IS 16362-2020, a specification for geotextiles used in subgrade stabilization in payments. IS 17312-20, specification for geogrids for flexible payments. IS 17373, specification for geogrids used for reinforced wire retaining structures. And IS 16345, a guideline for installation of geotextiles used in subgrade separation in payments. And IS 16380, test methods for measuring pull-out resistance of geosynthetics. Other than that, BIS and IRC are, as I told you, they are speedily working in drafting new codes also for the different applications of geosynthetics in various sectors. So looking into the compliance of Textile Geocell, the mechanical and endurance properties of Textile Geocell meets the requirements of MORTH Section 700 and Table 712. Well, Section 4.8.2 of IRC SP 59-219 also includes this table, which mentions the minimum design criteria or the minimum material requirements for Geocell. The strip cell wall thickness shall not be less than 1.2 mm. The seam peel strength shall not be less than 350 Newton per 25 mm of cell depth. Now talking about the rate analysis and the SORs, item number 50.37 of Maharashtra SOR and item number 26.18 of CPWD SOR 2019 both contain the specifications and the various variants of uniaxial geogrids used for basal reinforcement for embankments. Item number 50.38 of Maharashtra SOR 2019 provides the complete specifications and the rate analysis of the various variants of geocells which are used as basal reinforcement foundations. Now, as far as product testing is concerned, the important properties of geosynthetics, important properties of geogrids, important properties of geocells, of woven geotextiles and drainage composites like creep elongation, connection strength, tensile strength, and installation damage and durability, all are checked by BITRA Mumbai, that is Bombay Textile Research Association, and all our products are BBA, CE, and BVQI certified. Now, talking about an insight of installation procedure for Geogrid for ground improvement, it includes unrolling of Geogrid rolls, then overlapping of adjacent Geogrid rolls, and then dumping or spreading of fill onto the Geogrid, and finally compaction of the fill material. On the similar note, an installation procedure for Geocell includes foundation preparation, that is watering of foundation and then compacting it, then leveling the foundation after profile correction, then surface marking as per the width of the geocell, then unfurling of geocell, tying of geocell units with tying band, then dumping and spreading of fill over to the geocell, and finally the compaction of fill material. Well, before concluding, I would like to share some case studies of TechFab India, wherein we have just given our solutions for ground improvement applications in our own country. So the first one is development of integrated centralized parking zone for parking of tractor trailer at JNPT area. JNPT Port Authority, they have decided to build a parking lot at that time because they wanted to reduce the problems of stranded heavy trucks which were entering into the terminal. So they decided to build a parking lot, and the problem was the parking lot had to accommodate 1,553 trailer tractors. And for convenience, it was a condition that parking lot was built near to the port for easy access. Now the problem with the port was the site was near shoreline areas of near ports, and the foundation soil was soft marine clay. And though it was a parking lot, so it has to anticipate huge traffic loading of vehicles, standard vehicles. heavy trucks and trailers. So the solution which was proposed was Textile Geocell infilled with granular material at the base in conjunction with Geogrid for stabilization and stress dispersion. And a non-wound geotextile placed as a separator beneath the sand layer, which were containing 10 mm, 100 mm concrete paving blocks. These are some project photographs of the same site. This is the Geocell link and it separating in compaction, then a Geogrid link, and this is the link of non-wound geotextile. Another case study, well, this case study is about a housing scheme, about buildings. As I was talking about that ground improvement techniques, not only about roads and associated works, but still we can just employ the same technique under buildings also. One of the site at Andhra Pradesh, which was near to the coast, and the foundation soil was black cotton soil, which was having very low bearing capacity. And hence it was very difficult to adopt the conventional techniques of ground improvement. And in order to speed up the construction, TechFab India came up with the solution by installing Textile Geocell filled with granular material, which was intended to transfer the load pressure to the wider area in conjunction with polypropylene biaxial geogrid, polyester geogrid on the top.
Just to clear, Ishfaq, this is a low-level housing scheme, so only single-story building, so not for the multi-story building ground improvement.
Yeah, thank you
Yeah,
so much.
just
This is the image which will show you that the filling of the geocell with granular material. Some aerial images are there. Aerial view of raft foundation which was put onto this ground improvement, and then the construction of house or foundations were in progress while we were drafting this case study. Another case study was subgrade stabilization using Textile Geocell for Sion Panvel Expressway, Mumbai, Maharashtra. As I told you earlier, that subgrade stabilization can also be done by using this Geocell. So this is one of the projects wherein the client was PWD. Well, the problem from the photograph is quite evident. That is the presence of potholes in the incomplete portion of pavement, which was built using bituminous pavement. The stretch was 4 kilometers, and the problems after clearly analyzing the solution was that the base of the foundation was a marshy land, so it was unable to support adequate traffic loads for long time duration, and due to heavy traffic there were permanent deformations which were formed and which resulted into the formation of potholes after rainy seasons and all. So TechFab India came up with a solution of adopting Textile Geocell in combination with high strength woven geotextile as for a separate subgrade stabilization. These are some installation photographs when unfurled and Geocell was tied together. After then, this is the complete project photograph, and this is the cross section which was adopted. Here in beneath GSB layer, a Textile Geocell in combination with woven geotextile was used for stabilization of the subgrade. Well, before concluding, I'll say a few points that ground improvement using geosynthetics is technically superior and economical compared to the conventional ground improvement techniques. And since the initiatives of Morth and NHI, which specifies minimizing the use of cementitious material and reducing carbon footprint, our guidelines are intact with them, and the design methodologies and material specifications are included in the IRC standards and various SORs like CPWD SOR and Maharashtra SOR. Geosynthetic technical parameters all have been certified by Bombay Textile Research Association, and TechFab India, we comply to Make in India initiative with a motto of providing engineering and techno-commercial assistance to all stakeholders right from the inception of project to its completion. We have a motto of manufacturing highest capacities in order to supply huge quantities in short period of time as per site requirements. Our manufacturing is ISO 9001 quality certified, and our in-house laboratories are certified by NABL and GuideLab. Well, this was all about the ground improvement applications in roads and associated works. For any queries related to this session, you can write it to m.barot@techfabindia.com or i.hamid@techfabindia.com. Thank you so much.
thank you so much to everyone. You can write your query to both the email ID, and we will update you on our next webinar in short time. Thank you very much.